Hello everyone, welcome back to Kredict. This is day 41 of Learn Blockchain Development Challenge in just 45 days. And from today's video, we are going to start our new project, which is a decentralized to-do application. We are going to write smart contract for it, we will create a beautiful front end, and we also integrate it with our smart contract using Web3.js library, which we have already learned in previous videos. So first of all, we are going to write smart contract for it. So without wasting any time, let's get started. And for this, I'm going to use Remix IDE, and I hope all of you are familiar with this. So I'm quickly going to create a new file here. Okay, so this is the problem. I think you are familiar with this. Just reload the Remix ID and it will be fixed. Sometimes this happens. Remix ID goes blank and there is nothing to panic, just refresh and it will be fine. So just close this scam alert, create a new file. I'm gonna name it as todo.sol. Just minimize this. So here we are going to write a smart contract for Todo application. First of all, I'm going to define the license, which is spdx license identifier, let's say MIT. And next thing is pragma. Okay, it's auto completed, so I'm going to remove mine. Pragma solidity, and the version will be 0.8.20 and all the versions after this. You can check the current version here, which is 0.8.26, but I recommend you to use 0.8.20. Actually, this works after all the versions of 0.8.20 and 0.8.21 and so on. So there is no problem. And now we have to define our contract, which is contract to do list, we can say. Okay, so what is exactly a to do application? So all of you are familiar with this. This is just an application in which we write some task we have to do, and when the task is completed we mark it as completed, and when everything is done we can delete that task. Okay, so for storing tasks we need to create a structure for content, or you can say is it is completed or not. So for this we are going to use a structure which is struct, we can say task, and a string for content and a boolean for completed. Okay, so this is a structure, and now we have to create a mapping for our task, which is mapping uint unsigned integer of 256 bit and task public, and name it as tasks. Okay, and we can also keep a track of all the tasks we have, so you can create a global variable says uint 256 public task count. Just keep the t small. Okay, so we have now a structure and mapping and a global variable for keep tracking of how many tasks we have. So now we just have to create, you can say, 3 or 4 functions. First for creating a new task, second for if our task is completed, and third is for removing a task from a list, and fourth one is to get task details. Okay, so just quickly create all these 4 functions. First of all, I'm going to create a create task which says string memory, and we can say content. Now it's a public function obviously, And for now we are not keeping track of any account. You can connect with any wallet, create task. This is an open application, anyone can connect their wallet and create task here. You can also want to add the account based functionality that each user have their separate task. You can do by this yourself, because this is very easy and I've taught this thing in previous video already. So when a task is created, just mark task count plus plus. We are going to increment this and just create a task count, because we also want to keep the id of task and content, and by default it's not completed, so it's false. Okay, so this is the function which creates the task, and this is pretty much done. So just create next function, which is a complete task function, complete task. And for this we just want the id of task, so we can say un256 underscore id. This is also a public function. So let's check for if the task exists or not. So for this, if id is greater than 0 and should be less than equal to, what you can say, task count. Task id does not does not does not exist. Okay, so this is our check if task id is correct or not. And if everything is fine, we are going to just mark the task complete. So we can say tasks id dot completed equal to true. Okay, in this way we can mark a task completed. So this is also done. Now let's move to third function, which is a remove task. Let's create function remove task. We also want id here, so just id public function, and we also check if task exists or not. So let's copy this line, paste it here, and if task exists, just delete it. Delete, we can say tasks id. Okay, so creating task, completing task, and removing task. Now fourth and last function which we are going to require is get task. In this we are going to fetch the content of task using the id. So how you can do that? You can do this by function get task uint 256 id public, and also we are going to check here and just task. Okay, so we also have to return here, so just write it view returns string memory of content and comma bool completed. You can return the structure directly, but I want to keep things simple, so I'm just going to return a tuple of content and boolean value which is completed or not. So task equal to tasks underscore id, and with this just return task dot content comma task dot completed. Okay, so I think this function is also good. We have this structure, we have this. Let's check this. Just do a dry run here. Okay, so come to this deploy and run transactions, select any VM, or you can connect your wallet, but for now I'm just going to use the VM. The wallet is default here, which is given by remix ID from virtual machine. The to-do list smart contract, click on deploy. So here is our deployed smart contract. You can see we have some variables and some functions. First of all, I'm going to click task count, which is 0, obviously. Let's create a task here. So I'm going to write create a project. For now, just create a project. Click on transact. Transaction is successful, which means the task is created and task count is updated. So now if I want to get my task, I can pass the IDE, not IDE, actually ID, which is 0 for this. Just get task. Okay, I think there is something problem here. Okay, we have incremented, so by default the first ID is 1, not 0. My mistake. So 1 is create a project and complete it is false. So let's complete this task. How you can do this? Complete task, pass here the ID, click on complete task, and our task is completed. If you fetch again, you can see the task is completed. And if you want to remove this, just pass on 1 and click on transact. So the task would have been removed. Just click on get task, and you can see the country is empty and it's false, which means the task is already removed. And the task count is not changed because the ID is belongs to previous task. So if we create a new task here, create a project again, so this will not going to take the ID of 1, okay, because the ID 1 is belongs to previous task. That's why we have not decremented the task count. Just click on 2 and then you will get the second task. So that's why we have not decremented task count here while removing the task, because task count is still intact. Okay, so I think this is pretty much it. We can fetch task directly from here. You can see create a project again, task. But I think currently we don't have any option to fetch all the tasks in one go. So can we do this here? Okay, so let's create a function here which is going to return all the tasks in a single go. I think we should have to create a function for fetching all the tasks in one go. So let's create this also. So here I'm going to write a function and I'm going to name it get all tasks. This takes no parameter because we are fetching all of the tasks. It's public and returns a array of tasks. So we can say task array and memory. Okay, so first of all we are going to fetch or create a array which is going to hold all the tasks that are in the smart contract. So for this we have to create an array of task type, which is like this: memory all tasks equal to new. Yeah, this is a syntax for creating a array for a type. And we also have to pass the size for it, so we know how much size is required, which is task count. So task count. So let's write for uint 256 I, and starting from 1. Make sure this is starting from 1, not from 0, because our task count is starting from 1. I plus plus, okay, not I plus plus, it's I less than equal to task count. Okay, and then I plus plus, because we need to increment our counter by 1 each time, and assign the all tasks I to tasks I, and finally return all tasks. So there is something interesting. Okay, so let's make it a view function, because this is not writing anything on the blockchain. Okay, so I think now our final function is completed. Just delete this one, deploy it again. Okay, so here we go. We have now get all task also. If we click on this, you can see the string is empty. Let's quickly create a task here. Just checking, click on transact, and if you click on get all tasks, okay, here is something wrong. The transaction has been reduced. Okay, there is something not right. Let's see. Why is this not right? Okay, okay. Because all task is always starting from 0 and this is I, so we have to write here I minus 1 because all you know, let me explain this, that our task count is starting from 1, but the default design of arrays to get started from 0. So we are going to map like minus 1, so it's like the place of array 0 is mapped with task count 1, the 1 with 2, the 2 with 3. I think this makes sense. So I have corrected this here. Let's redeploy and test it again. Just click on deploy, open this up, create a task quickly here, doing something, click on transact, get all tasks. So you can see we have this array element doing something and it's false, and we can also mark it complete. Let's pass the id 1. So here we go, just get task, and you can see it's true. Let's see what will happen if we remove this. Just click on remove, the task is removed. Just click on get all task. So you can see we only get false and there is empty. So you can check this in front end that if the content is empty, then we are not going to display it on front end. This means the task is completed and removed. Okay, so yeah, it's working fine. Yeah, it's one content is empty. Let's create something new, something else here. Let's click on transact. So let's pass 2. Yeah, something else, completed false. 2, remove, get task, it's empty. Yeah, everything is working fine. So with this, our smart contract for our Todo application, our decentralized Todo application is complete. And from next video, we are going to integrate with our front end. Before that, we will create a beautiful front end for it, and then we will integrate and test it in upcoming videos. So till then, keep watching Kredict and stay safe. I will see you in next video.